from esteemed federal universities of Federal University of Petroleum Resources, FURUM, that's FUPRI in Warri. Presently, Rotimi holds a pivotal role at Accrete Energy Limited, where he adeptly amalgamates his profound engineering acumen with advanced software development skills to address intricate challenges within the dynamic oil and gas industry. Worthy of note is Rotimi's proficiency in utilizing AXIS software for hydrocarbon accounting, showcasing his adeptness in navigating complex processes crucial to the industry. Additionally, Rotimi's expertise extends to the use of integrated production modeling tools, which underscores his comprehensive skills in optimizing production processes and resource management. So it is our pleasure to have Engineer Rotimi. He's going to be talking on hydrocarbon accounting, basically. So I want us to be attentive, our mics muted, and our pen and paper ready to learn, because Rotimi has a lot to offer and offer to us and in the industry at large. So with this little introduction, I would love to leave the mic to Engineer Rotimi to take off from there. Thank you very much.
Okay. Thank you very much, Osawugwe. So please confirm that you can hear me clearly.
Yes, I can hear you. I can hear you.
So good morning, all. I welcome you to this session of webinar on hydrocarbon accounting in the oil and gas industry. Okay, so moving on. Okay, these are the outlines that are going to be covered today in the course of this webinar. So we'll start by introducing our company's services. Then we'll proceed to introduce hydrocarbon accounting, the basic concepts, around it. Then we'll move on to production measurement, deferment, allocation, and then we'll discuss the AXIS hydrocarbon tool that we'll make use of in our company. Okay, so what are our services? So we are into software deployment of integrated production modeling suite, which encompasses the state-of-the-art Prosper, Embal, and GAP for managing our oil and gas services. Then we're also into digital oil field services or suite. Then hydrocarbon accounting. They also offer consultancy services like integrated asset modeling and production optimization. Then other consultancy services includes wireless and remote field data gathering system that collects data in real time from the field, more or less like a telemetry system. And then this data can be monitored in real time, right, in the office or workstation, as case may be. So we also offer training, and highlighted on the screen are training courses on IPM and AXIS hydrocarbon accounting, petroleum engineering courses, and other petroleum business-related courses. We're also involved in other oil field services like wireline and sickline services, directional survey services, which is called gyro, completions and supervision services, drilling supervisions, and manpower services. Having said so, we'll proceed to the business of the day, which is hydrocarbon accounting. Okay. As production commences in a typical oil and gas field, the resources emanating from different wells are channeled to a separator, as we all know. And this separator is made to separate the crude into oil, water, and gas components. However, depending on the completion types of the different wells in the field, it is important to calculate the contributing volumes of each stream coming from the different wells into the separator and the latent. Okay. So after the initial drilling and production, the resources are separated and custody or ownership of this oil is typically transferred from an upstream producer to a midstream oil and gas company. As can be illustrated on the screen, you can see, the oil produced from the wells goes to the separator, and then from separator it goes to the midstream sector, and then it's transferred to a custody transfer unit for measurement, and then whatever you choose to do with the crude, whether you want to pass it into a trunk line or export it, okay, you can do it with it. But then there's a problem, okay? Managing commingled flows from different companies by calculating the contributing volumes made by each party becomes difficult because the volume that is measured at one point of the production system is usually different from the volume that we recorded at another point. That's because the crude is highly sensitive to pressure and temperature changes, and due to the sensitivity, okay, when the pressure goes below the bulk point pressure of the fluid, what happens? Gas begin to evolve from the crude, and then it causes the crude to shrink. So you now experience the shrink by the volume that you recorded at the well, okay, becomes different from what you record at the flow station, and it even reduced further by the time it gets to it. So now, how do we now calculate the contributing volumes from each of these wells to the LACT unit? Okay, it becomes very complex, and then it leaves a big question to be answered. Okay, so what are the pending questions that we need to answer given the situation at hand? Okay, so one of the questions is how much of this oil and gas belong to each contributing party? Okay, so you need to understand that depending on the nature of your oil field, okay, you can have many wells in your oil field, and these wells can, depending on the completion type, can be dual stream completion, where you can have like two streams in the well. Okay, so as an hydrocarbon accountant, you want to be able to account for the volumes of oil that each of these streams contributes to the flow station, and also contributes to the LACT unit. Okay, so how do we establish or determine ownership of these contributing volumes from each of these parties? So that's one question that we need to answer. Then the second question that we need to answer is, how do we establish ownership of these resources? Okay. Yeah, how do we establish ownership of these resources, considering that there are different, joint ventures or partners that have different maybe LACT units, and we want to establish ownership, right? So let me give a more detailed scenario. Let's look at a situation whereby company A, okay, has their own oil field, and then whatever they are producing goes into a trunk line, and then another company called company B has their own oil field, which they channel into the same trunk line. So how do you establish ownership between the two parties? So these are the questions that we're going to answer going forward in the course of this presentation. So the solution to these questions is hydrocarbon accounting. Okay, so hydrocarbon accounting, it's the only way you can be able to account for the contributing volumes from each party, and this is what solves the problem. So what is hydrocarbon accounting? Okay, so hydrocarbon accounting is simply a system by which ownership of gas, oil, and water is determined and tracked from the point of production to the point of sale or discharge. So hydrocarbon accounting is what gives us the solution to the problem that I highlighted earlier on in this presentation. So, but we'll find out how hydrocarbon accounting is able to do this in subsequent slides. But basically, or in this snapshot, you can see these are the features of hydrocarbon accounting: production allocation, production planning, and it acts as a cash register. So it enables us to perform reconciliation, okay, of our volumes from the wells to the flow stations and from the flow stations to the labs. Without talking much, we'll find out in subsequent slides. So going forward, what are the key processes of hydrocarbon accounting? Okay, so they are production planning, production measurement, production deferment, production allocation, and production reporting. So we need to be able to plan, okay, how much volumes can we make, at the end of this month from this field or from this field station. Okay, so as global accounting, when you're able to account for the volumes of oil and gas that are produced from the different wells in the field, and you're able to attribute these volumes, right, adequately or appropriately, it gives management the opportunity to make accurate decisions and that management decisions. Yeah. So we'll start with production measurement. Okay. So before you can, account for the volumes at all coming from each of these wells, you need to be able to physically measure the quantity of, of your crude oil and gas that are coming out from your oil field. And how do we do that? We need physical, equipment and devices to be able to achieve that. Okay, so examples of hydrocarbon measurement devices are the LACT unit, the PD meter, the Coriolis meter, the turbine meter, the auto sampler, orifice meter, and the ultrasonic meter. Okay, there are lots of meters available, but these are the few that are highlighted in this our hydrocarbon accounting session. So we're going to go into some of these measurement devices and explain how they work and the principles, guiding them. So starting with the LACT unit, what is a LACT unit? Okay, so I don't know if any of you have heard of a LACT unit, or you've, maybe studied it in the material somewhere. So, but in the course of this session, we would explain what a LACT unit means. Okay, so the term LACT stands for Lease Automatic Custody Transfer. Okay, so it's basically a piece of oil and gas equipment that is used to measure the quantity and quality of crude to be transferred from one company to another. Okay, so we not only want to determine the quantity, but also want to establish or be able to determine the quality of this crude. So the LACT unit assists with that. So it has different components, which are the pump, the BS&W monitor, the air eliminator, and other components, as you can see displayed on the screen. So we're going to explain briefly what these components stand for and how, they work hand in hand to, to achieve the major objective, that is to measure the quantity and the quality of the crude. Okay, so how does the LACT unit work? Okay, so the crude emanating from the flow station flows into a storage tank in the LACT unit. Okay, so if you look at this diagram, you see that there is, to the left of the diagram, you see it on the screen, you see that there's a tank there. Okay, so the crude coming from the flow stations enters into that tank, and then there's a pump, as you can see on the screen, that draws the oil from storage tank into another section called the BS&W, okay, monitor. So the BS&W, as you all know, is the basic sediment and water. So what the BS&W monitor does is to measure the levels of BS&W contained in the crude. And then from there, the process fluid moves into another section called the air eliminator. Okay, so when food have maybe air or gas in it, the quality of measurement is affected by the time it goes into a meter, maybe a flow meter like Omonusi meter or PD meter. So, and we want a precise measurement as possible. So we have to remove anything that would hinder us from having precise measurement. And so that's why the air limiter is there to remove the gas or air from the crude that might affect the quality of the measurement. Okay, so that's the air eliminator. Then there's an inlet mixer, right? So after the process fluid moves from the air eliminator, it goes into another section called the inlet mixer, right? So what the inlet mixer does is that it emulsifies the liquid so that accurate volume measurement can be ensured. Okay, so if there is two-phase flow in the pipe, what happens is that the meter may not be able to give accurate reading for the fluid, because it might give reading for just one phase of the fluid. So, but we want to agitate the fluid a little so that so as to enhance the quality of measurement. So what the inlet mixer does is that it emulsifies the liquid so that we can improve the quality of the measurement. Okay, so from the inlet mixer, the fluid goes into a three-way diverter valve. Okay, so what this valve does primarily is to channel this fluid to its appropriate destination. So there are a series of tests that will occur in this three-way valve. First, it needs to ensure that the fluid, that is the PS and W content in this in the fluid, is within the acceptable limit, right? So if it is not within the acceptable limit, what it does is that it moves this fluid into another separate tank called the bad tank. Okay, so that bad tank will now use natural techniques to separate this PS and W from the crude, right? And then we channel the crude back into the unit for further analysis. Okay, so if the PS and W, right, content in the crude is exceedingly high, so the three-way diverter valve will now channel this fluid into another separate chamber called the heating chamber. So what the heating chamber does is that it heats up the fluid to reduce the PS and W content before it now reroute it back into the LACT unit. So if the three-way diverter valve, okay, checks it and sees that the PS and W content is within acceptable limits, what happens is it then channels this the fluid into, or the stream into another section where the Coriolis meter is, or a flow meter is, for measurement. Okay, so in subsequent slide, we would discuss how the Coriolis meter works. Okay, so what is a Coriolis meter and how does it work? So a Coriolis meter is an example, it's a typical example of a flow meter, right? So there are other flow meters available. We have the PD meters, we have the ultrasonic meters, we have, okay, so these are basically flow meters, right? And the Coriolis meter, how does it work? So it uses the principle of motion mechanics, which means the meter basically splits the process fluid into two coils, okay, oscillating in opposite directions. So as you can see, it's displayed on the screen. There are two coils there, and then the meter splits the fluids into these two coils, and then the coils are made to oscillate in opposite directions. And then when this oscillation starts, vibrations is generated, sine waves are created, and the time delay in motion is proportional to the mass flow rate. So this is how it calculates or determines the flow of the stream. the stream, right? So from the Crowley's meter, where does the stream goes into? Okay, so the stream moving from the Crowley's meter goes into a set of valves, the back pressure valve. Okay, so what this valve does is, okay, the valve also has a proving connections there that houses proving meters. So we want to ensure that what was measured in the Crowley's meter, is correct. So we want to not to increase or improve precision. There has to be maybe a proving meter in the back pressure valve and proving connection section, just to verify the precision of what was measured in the Crowley's meter. And then from this valve, it goes into another valve called the check valve, right? So what the check valve does is that it prevents the backflow of the measured stream into the lacting. So after this stream has been made to pass through all these many sections, and it has measured in the Crowley's meter and the proving meter, we don't want this fluid to go back into the lacting. So the check valve is there to ensure that. Okay, so from the check valve, where does the stream go? Okay, so after all this, the pressure of the stream will have been very low, usually now be within 45 psi. So then we need to energize this fluid, because we need to transport the fluid to other booster stations or to another midstream sector. So to do that, we need another pump called the PCP, which is the progressive cavity pump. Okay, so what the pump does is that it increases, the pressure of the fluid so that it can be transported to other booster stations or its final destination. Okay, so now I want to believe we now have a first-hand information or knowledge of what a lac unit means. Okay, so moving on, we're going to talk about the positive displacement meter. So how does it work? So basically, pockets of fluids are trapped between rotors housed within a high precision chamber. As can be seen displayed on the screen, you can see that there are two rotors gliding against each other, and then the stream is made to flow into these gliding rotors. So what happens is that the rotational velocity of these rotors is directly proportional to the flow rate of the moving fluid, and that's how the PD meter calculates or determines the flow rate of the fluid or the stream moving through it. Okay, so for the sake of time, I won't be able to explain all the types of meters available, but there are also other types of meters that are very useful in the oil and gas industry, like the orifice meter. The orifice meter is not a direct meter like this. Okay, this is an indirect method, that is pressure differential, that is the P, to measure the flow rate of gas most of the times. Okay, it's used for gas measurement, and then also have ultrasonic meters too that use the propagation of sound waves or signals to determine the flow of the stream passing through it. Okay, so production measurements can be done in different sections of an oil field. As can be seen on the screen, you can see that there are wells flowing into a flow station. Okay, let's call that flow station A. And then in this flow station, there are meters, installed in that flow station to measure the quantity of, the flow rates of the wells, right? Then we also have to measure them, right, before joining them into a lac unit. It's called the alpha lacs. Now, this lacs will now measure the combined volumes, right? So you see now that, you've measured the volume at the flow station, at the different flow stations, and then all these volumes now are now channeled to another unit called the lac unit. So this lac unit now takes the combined volumes of the entire stream. So now how do we now appropriate that, or allocate the volumes to the well? How do we establish the contribution of each of these wells to the last unit. So that's where hydrocarbon accounting comes to play a very huge role, if you understand what I'm talking about. So moving forward, at this point, I would like to, ask the audience some questions just to be sure that you've been following all this while. Okay, so let's pause for a minute and have a pop quiz. So you can check the chat box for the questions. And then if you have answers to the questions, you can just post your answers. I just want to ensure that you are following. Okay, so the first question has been posted. Okay, any other answer? Okay, thank you, Osarogwe, for your answer. Okay, Mr. Ajoke, thank you for your answer. Okay, feeding meter, that's correct. Service meter, you are doing well. Okay, so you all have been following. Okay, nice. You're on your way to becoming an hydrocarbon accountant. So we proceed to the next question. You're all correct. Okay, so the next question we posted shortly. So which of the flow meters measures flow by using two splitting oscillating coils? So that's the second question. Okay, which of the flow meters measures flow by using two splitting oscillating coils? Okay, there's one answer already, posted already, but I need more answers. Okay, so 30 more seconds. Any more answers? Okay, so if your answer is Coriolis meter, you are correct. So that's fine. Let's proceed to the third question. So the third question we posted shortly. So name one of the processes of hydrocarbon accounting that you know. Okay, I'm still expecting an answer for the last question. I think you posted. Yes. Okay, I can see answers. Thank you, Awadi Peter. Okay, deferment, yes. Yeah, production deferment, production planning. Okay, thank you, Sonyi. Thank you, Mr. Osarugwe. Production allocation, that's correct. Okay, production reporting, that's fine. That's reasonable. Thank you very much for participating. in this quiz. Yeah, so I'm very confident that my audience have been following me all this while. So let's proceed to the next section of this webinar. Okay, so moving on. To production deferment. Now we know how production measurements occurs in a typical oil field. Okay, we know the different measurement devices or equipment available in the oil and gas industry. Now, let's narrow down to the hydrocarbon accounting concept gradually. Okay, so production deferment. So what is production deferment? Okay, so deferment basically is the reduction in production caused by an activity, breakdown, trip, poor equipment performance, etc., that results in reduction in volume sold, thereby delaying production until later time. So without using much vocabulary, what deferment simply means is, okay, we want to account for the volumes of crude that we did not produce, right, within a period of time. So there are concepts that are used in hydrocarbon accounting, for deferment. So we have uptime and we have downtime. Okay, so typically your wells are meant to flow for 24 hours in a day, right? So if that's the case, if the well has been flowing for 24 hours of the day, it means that that's the uptime, right? So, but sometimes the well can be just flow for like maybe 18 hours, and then in the next 6 hours, we have to perform well tests on that well. So for that 6 hours where we were performing well tests, okay, what happened? You were not actually producing per se. So production has been deferred, okay? And we also need to account for the production that was not made, right, due to an activity that was performed in that well, right? So it could also be due to some other issues. It may not necessarily be due to the fact that it's an activity. It could be that maybe it's a safety procedure. Maybe the well, we have to, shorten the well for a particular reason or so. So detailed tracking of the reasons for deferment for any period of time provides valuable time-sensitive insight into necessary remediation measures to get wells and facilities back to production. Over time, it also provides awareness around trends that may be occurring from specific wells, facilities, or pieces of equipment. Okay, so that's pretty much all about production deferment. Although when we start production allocation, you understand the importance of production deferment. You appreciate the importance of production deferment better. So what is production allocation? Okay, so allocation is the process of recalculating the contribution of various streams to commingled flow depending initially on the flow measurement. Okay, so you see that all these hydrocarbon accounting concepts are interwoven and interconnected. So if you don't understand production measurement, you may have issues or difficulty understanding production deferment or allocation, because before you can perform allocation, you first need to measure, the volumes coming from the different contributing streams. Okay, so what allocation does is we need to back allocate, the production of oil and gas or water back to flow stations or the wells or even the pay zones if need be, depending on the requirements of the clients. So in other words, allocation is a term used to describe the system by which ownership of oil, gas, and produced water is determined and tracked from the point of production to the point of sale or discharge. The allocation system therefore has a direct impact on revenue, right? And this makes hydrocarbon accounting the cash register of a producer's oil and gas business. To carry out allocation, the entire allocation process is divided into tiers. Okay, so there are concepts, basic concepts that will enable you to understand production allocation. So one of the concepts is tiers, okay? So tiers are basically nodes, right? So if your wells, if there are like 3 wells in the field, or let's say 10 wells in a field, and then those 10 wells are routed to, let's say, flow station A, right? So that's one tier there. So you see there's a node, 3 combining volumes going towards one node, which is the first flow station. So that we can call that tier A. And then the second tier could be that, okay, there are different flow stations, right? So different flow stations, right? And then those flow stations, the volumes from those flow stations are combined, okay, into another node, and then they are made to flow until one particular lat. So that's another tier, tier 2, right? Then tier 3 could be that, okay, this lat, there are different lat units by different organizations, let's say company A, company B, company C, right? The volumes, right, emanating from the different lat units are made to converge at that point. And then at that point, let's say it's a major trunk line, and then it flows from that trunk line to its appropriate destination. So that can be tier, another tier, tier 3. Okay. The essence of this tier is that we need to be able to establish, ownership, of oil and gas from the different contributing parties in the entire production system, right? So from the upstream to the midstream, and even to the downstream sector. So we need to be able to back allocate. And why are we back allocating volumes? I mentioned it before that whatever volume that you recover from the well, it's not the volume that you recover at the flow station. Why? Because of shrinkage, right? So by the time crude is made to flow over long distances, it shrinks, right? Due to reduction, changes in pressure and temperature conditions. And then when it goes below both points, gas evolves, and then the crude oil shrinks in volume. So when it shrinks in volume, you need to, recalculate the new volume of the different streams that were made to flow into the flow station. And then from the flow station, if you flow those streams from the flow station into a lat unit, the volume will be reduced further. So you see, you have to start from the known to the unknown. So you start from the lat unit, right? And then you back allocate to the flow station. And then from the flow station, you back allocate back to the wells. And from the wells, you can back allocate to the pay zones if need be. Okay. So for instance, we can also perform daily allocation, okay, where you back allocate daily volumes of gross liquid, net oil, and condensate, or even water from the lag to the flow station or gas plants, and from the flow station or gas plant to the wells. So it also calculates the production allocation, allows you to calculate the daily volumes of gas for each well and flow station or gas plant, as the case may be. So what are the types of production allocation that are available? So there are different types of production allocation, different material with their different types, but in simple terms, production allocation is broadly classified into 2: physical allocation and field allocation. So these are the 2 broad categories of production allocation. So the first category, being physical allocation, involves apportioning volumes to individual contributing fields or owners based on agreed methodology specified by the parties in their commercial agreement or contract. It forms the basis for sales revenue to the owners of the field. So in simple terms, physical allocation is performed in, when there are different joint venture partners or joint venture parties involved. Let's say there are like 2 companies, just as illustrated in the first diagram to the left of your screen. So you see company A, company B, company N, right? So there can be multiple companies, right, flowing their crude into a major trunk line. Okay, so company A is flowing to this trunk line, company B, company N, they are all flowing to this trunk line. And before they flow to the trunk line, they must have their LACT unit, right, that measures the quantity and the quality of the crude. Because you can have maybe you can have a production of, let's say, 3,000 barrels, right? And then your water cut or BS&W is, let's say, 70%. And meanwhile, company B could be producing at, let's say, 2,000 barrels, and its water cut is 20%. So you see that the volume of company B is actually higher than that of A. So you need to be able to ascertain the quality of the crude from flowing from each party into the trunk line. And then where there's a problem is when, after flowing all these volumes that you've measured into the trunk line over a long distance, and it gets on that terminal or LACT unit, the volume is reduced, so you still have to back allocate. So this back allocation is called fiscal allocation, right? So because you're trying to apportion the volumes to the different contributing parties based on fiscal policies or based on the agreements that you've had in the beginning of the contract. And then the second type of allocation is the field allocation, which is basically apportioning volumes to contributing zones and wells, and then provide required data for reservoir management, well performance, and process facility operations. So this second allocation type, you're just trying to understand or calculate the contributing volumes of each of the wells to your LACT units, right? So let's just take company A, for instance, right? So company A performs field allocation, right, before they move to their, whatever, into the trunk line. So if company A wants to, know the contributing volumes of each strings from its oil field, right, we have to perform field allocation, right? Because company A will have to back allocate the volume that is recorded in the LACT unit. We have to back allocate that volume to the flow station. Then from the flow station, we'll back allocate back to the wells. Then from the wells to the pay zones. Okay, so this would help them to understand how much each of their wells are contributing to their LACT unit or to their revenue, so that they can know how much to spend on that well, so that they can make more production in the future. Okay, that being said, let's move on to production allocation calculations. Okay, so in a jiffy, I'm going to explain how we perform production allocation calculations in the oil and gas industry. So let me fully explain some concepts that you need to understand. So there's the gross liquid. Okay, I want to believe that the majority of us here on the call are petroleum engineers, so you must have heard of this. So the gross liquid consists of both the quantity of oil and water. Let's call that X barrels per day. And then we have the BS&W, which is the fraction of the gross production rate, that is water. So the fraction, so whatever you are getting from your gross, the fraction of that, the production rate, right, that is water, in percentage is your BS&W, which is your basic sediment and water. And then the water volume is calculated by multiplying, the water rate is calculated by multiplying the water cut, right? You multiply the water cut by the gross, multiply it to the gross, and then you get your water rate volume. Then the net oil is simply derived by multiplying, okay? So the gross X, multiply the gross X by 1 minus the water cut, so you get the net oil. Okay, I want to believe you understand that. So moving on to well allocation, the oil rates gotten doing well tests from each well, let's call that oil test rate. So let me explain this to you. Typically, in the oil and gas industry, let's assume that company A has an oil field. Let's say the oil field is field X, right? So let's assume that field X has, like, let's say 100 wells. So it is not economically wise to install meters in all the 100 wells because it will cost you a lot of money. Right? Even if you have the money to spare, it's not wise to do. So we could explore another alternative, to still get the rates from these wells by performing surface well tests, right? So, and the well test is often performed by, flowing the well to a test separator on the surface, and then you flow it for a period of time. Then you record the volume that you flow that you made to flow into the test separator. You divide that volume by the flowing time to get the flow rate. So that's how the rates of most wells are usually got in the typical oil field. So the concept of production allocation, underscores that too, right? It takes cognizance of that approach. So that's why we have this oil test rate here, OTR. So now, for well 1, you have the oil test rate for well 1 as OTR1, for well 2 as OTR2, for well 3 as OTR3. Now, in order to account for production deferment, we need to make use of the uptime hours, right? So if your well has been flowing for 18 hours, it means it has an uptime of what? Of 18 hours and a downtime of what? Of 6 hours. So basically 24 minus 18. So uptime is basically is the mathematical term that is used to account for deferment in the, in a typical hydrocarbon accounting procedure. So in our calculations, you have to observe that too. So the uptime hours for each of the wells, let's denote that as UT1, UT2, and UT3. Okay, so now to calculate the unreconciled production, that's UPR1. For well 1, you have to multiply the oil test rates of well 1 by the fraction of the time in which it has been flowing. So if that well was flowing for 24 hours, then certainly it will be 24 by 24, right? Multiplied by the oil test rate. Okay, and that will give you your unreconciled production. But if they were deferment of any kind, so what will happen is you measure the uptime hours. Okay, so let's say the well was just flowing for 8 hours. So you have to calculate, the fraction of, the time that, that well was flowing. Then, so you have to get your unreconciled production rate. So I want to believe you understand what I mean. So then, to calculate the reconciled production. Now, this term unreconciled and reconciled. Okay, let me explain the term briefly. So the unreconciled production is, okay, the production you get at the well, right? At the well. So, but you know that by the time this stream flows from the well to the flow station, and then from the flow station to the lat, the volume will reduce further. So, and then you have to reconcile the volumes, right? So to reconcile the volumes back is to account for the fact that, okay, the volumes are experienced shrinkage, right? Due to the fact that it was made to flow over long distances. Then you have to reconcile the volume. So that's just what the term stands for. So to calculate the reconciled production for well 1, what we do is we calculate, okay, the unreconciled production rate for 1 divided by the unreconciled, the sum of all the unreconciled production rates of all the wells, right? Then we multiply that by the net oil from the flow station. So what has this done? We've just reconciled the volume from the flow station back to the wells, right? So, but allocation starts from the last, from the last tier. Okay, so if we have, made our stream to flow from the well to the lat and want to do back allocation, we have to start from the lat unit, right? So start from the lat unit to the flow station, then from the flow station, we back allocate to the wells, and so on. And then the calculation of back allocation is pretty much the same. formula that you see here, except that you just have to like understand the contributing volumes. So in the case of the flow station, instead of having the oil test rate, you have the meter readings, right, from the flow stations. The meter reading for that flow station divided by the meter reading of different flow stations. Okay, that's if you are back allocating from the LACs to the flow stations. So that's basically it. So I'm going to like give you an example here. So if you look at the schematic on the screen, you'll see that there are 3 wells flowing into company A, right? LACT unit. So these wells are flowing straight to the LACT. So this like okay to the flow station, sorry. So it flows to the flow station, company A flow station, and then company B flow station has its own flow, but I think we didn't see the wells. Then this company B and company A joined, and then were made to flow into a LACT unit. So first thing first, if you look at it, how many tiers are here? Okay, so there are 2 tiers. There are 2 tiers. So first, the first tier from the end to the beginning. Okay, so the first tier is these 2 junctions, the junction in which company A and company B meets, right, at the LACT unit. So that's the first tier. So company A and company B commingled, right, at the LACT unit. So that's the first tier. Then the second commingling that happened was at the wells, right? So the 3 wells commingled at this junction, right, into company A. So that is tier 2. So tier 1 in the LACT unit, tier 2 in the 3 in company A, if you understand my explanation correctly. So now, looking at the flow rates, that's the oil test rates that were gotten or obtained from the wells, you can see that 200 barrels was flowing, right? Yeah, well, one was flowing at 200 barrels per day. That's the test rate, the oil test rate. And then you can see that well 2 was flowing for 150 barrels per day. The well 3 was flowing for 100 barrels per day, but only flew for 12 hours. So we need to calculate the unreconciled volume for well 3 because we need to account for deferment, right? So it was flowing for 12 hours, means that for 12 hours, the uptime is 12 hours and the downtime is 12 hours. So we need to use that uptime calculation that was illustrated in the previous slide to calculate for the unreconciled production rate for well 3. And how do we do that? You just, 12 divided by 24, you multiply it by 100 barrels, and that will give us 50 barrels per day. So now we know the unreconciled volumes of each of the wells. But then how do we back allocate the volume from the LACT to the wells? Okay, so we'll start that gradually, moving from the end to the beginning. So from the LACT unit, okay, from the LACT unit, you can see to the left of the LACT unit, you can see 290 barrels there. Look at to your right. Look at your right, the LACT unit. The volume at this LACT unit is 290 barrels. And then by the time you sum the total volumes from the well test, okay, from the well, you discover that the volumes are 50 plus 150 plus 200, 400 barrels. Right? You see that it's higher than what we have here. You see, that is due to what? To shrinkage. Shrinkage has certainly occurred. So we cannot say that the volumes are 200 barrels. We need to, apportion new volumes to these wells, accounting for the shrinkage that has occurred over the long distance of travel of the streams from the wells to the LACT unit. So doing that, we first back allocate from the first tier, which is tier 1. So already company E was recorded to have 250 barrels, right? And company B was recorded to have 100 barrels, okay, of volume. So if you sum that, that is 450. Well, here it's 390. So let's back allocate and get new volumes of the two parties, party A and party B. So doing that, you use that allocation formula that was illustrated in the previous slide. Okay, so for unconsigned production, so what you simply do is, okay, the unconsigned production for company A will be 350 divided by the sum of the two volumes, that is 350 divided by the sum of 350 plus 100, which is 450. Okay, then you multiply that by this barrels, the volume at the last, which is 390, and you get that 303 barrels approximately, and then you get 87 barrels for company B. So now we have new volumes apportioned to the different parties, party A and party B. Now we want to recalculate the volumes, the contributing volumes from the wells to company A, right? So how do we do that? Now note that the new volume at the lactons of company A is now 303 barrels as opposed to the 350 barrels that was there initially. And so if you do the same calculations, you get that. So without wasting much time, let's move to the axis hydrocarbon 2 section. We'll spend quite a while, but let's see how far we can go. So there are different software that can be used to perform hydrocarbon accounting out there in the industry. But in Accrete, we make use of the Axis hydrocarbon accounting system or tool. Okay, so I'll explain to you the features briefly. So these are the features of our hydrocarbon accounting tool, Axis. So sample analysis, forecast, metadata, validation, allocation, audit logs, approval, reporting, etc. Okay, going details into what the tool stands for. Okay, so looking at the field data, Axis gives clients the opportunity to get data in real time from the field, right? Using SCADA systems. So it's possible to get real-time data from the fields and then into the tool. So you don't have to manually input it yourself. And then tasks can be automated in the system. So you don't have to do the process manually all the time. So also can also act as a repository for storing your data so that you can make reference to them at your will or at your own time. So all the processes of hydrocarbon accounting that we mentioned earlier on in the course of this presentation can perform from your production allocation to reporting to measurement to name it. So you can do virtually everything on the Axis tool. So it makes use of a structured database, right? MS SQL for storing data, and these data are properly structured that you can make reference to it at will. Okay, so reporting too is another very good feature that you can enjoy from using the tool, because you don't have to start creating reports manually on Excel. It can be time demanding and stressful, and you want to reduce non-productive time as much as possible, in your oil and gas processes. Then another reason for reporting is that based on the regulatory body requirements, okay, you need to submit reports of whatever you are doing in your oil field. They need to be aware of it. So there are reports that you have to send maybe quarterly, annually, or even monthly, as the case may be. So to perform reports, and you need to make reference to any of your reports at any point in time, right? So redundancy too is also reduced. There's data security, there's data integrity, which means that you can't store a particular value today and then the value is something else, somewhere else. So there's data consistency. The redundancy is reduced to the barest minimum, okay, because the tool makes use of a structured database. Okay, so moving on to the Axis architecture. Okay, so it makes use of Microsoft technology, which primarily runs on Windows. So there's the application server, and there's also the database server. Now, the database server can be hosted locally or on the cloud, right? Depending on whatever the client wants. So if you want your database to be in the cloud, you can, opt out for that option, opt out for that. And then there's also the client, there are also client computers. So the client computers are made to point to, the application server and the database server too. So whether it is local or on the cloud, you can also point to them. The tool runs on the browser. So you can, the deployment is pretty much easy. You don't need to install rigorously on different PC. All you just need to do is to ensure that they are on the same network, and then you are good to go. So thank you very much for paying attention to this webinar. At this point in time, I would like to entertain questions from the audience. So if you have a question, simply raise your hand, and then you'll be unmuted so that you can drop the question. Or you can also drop the question in the chat box. So that's options there. So if you have a question, just signify by raising up your hand, or just drop your question in the chat box. Thank you.
Okay, thank you very much, Engineer Rotimi. That was a very spot on webinar with you. We honestly really appreciate. So currently we're in the question and answer session. The floor is open to anyone with questions. Engineer Rotimi has dealt very well on this topic. Hydrocarbon accounting and back allocation is a big challenge in the oil and gas industry. Having to calculate or back calculate the contributions of either fields or wells or even pay zones for that are contributing to the sum of production is a very big task. So thank you very much, Engineer Rotimi. Do you have any questions? You can drop it on the chat box or raise your hand, and you'll be unmuted to ask.
Okay. Okay, how do you back allocate condensate scored from a gas plant for which 2 flow stations contributed for the gas compressed and the liquid condensate pumped? Does Axis tool enable real-time data stream to it like OSISOFT PI2? Can Axis automatically inform key stakeholders if custom production reports are ready? Okay, so is that the other question? Let's see the other questions. Okay, so in the answers of other questions, let's look at there are so many questions here. I'm trying to pinpoint them one after the other. So from what I understand here, You are asking, how do you back-allocate condensate scrubbed from a gas plant, okay, for which 2 flow stations contributed for the gas compressed and liquid condensate pumps. I'm not sure if I understand that, but if you're trying to like back-allocate from your flow stations to your gas plants, right? So you can pretty much make use of the field allocation approach, where you just simply sum. Okay, so you take the unreconciled volume, you divide it by the sum of all the the unreconciled volumes that from that uh, flow station, right? So then multiply whatever value you get, you multiply it by what you are getting at the gas plant. So that's how you back allocate from the gas plant to a flow station. So I'm not sure I got your question correctly, but if you can unmute and ask out yourself to clarify, I would appreciate that. Mr. Sonye. Okay.
Hello, Rotimi.
Yeah.
I think you throw more light. Say you sum the two the produced volumes from the flow stations.
Okay.
Then did you say you multiply to the condensate? Like a proportion.
So I'm trying to get the flow, right? The flow system. So is it that the gas stream is flowing, from the flow station into another gas plant? Because
Okay, let me just paint the picture. So like you have maybe like two different stations with the wells. So they produce
okay.
no, the gas produced from those stations. You cannot flare them. So you take it to the gas
Yeah.
plant. So the gas
Okay.
plant. And so at the end of the day, for you to have a valuable gas can be commercialized, it needs to be scrubbed. And at the end of the day, you have condensate.
Yeah, I got that. Okay.
So that condensate now, so you don't have to, you can't throw them away. You have to back allocate it to the reservoir or to the wells that contributed for it.
Okay. So
Mm.
that would be a bit okay, because condensate volume, except you are able to calculate the volume of condensate before it is being scrubbed. So now you want to back allocate the volumes from that gas plant to the wells. Is that what you're asking?
Yes.
Okay, so depending on the
No,
calculation
but
procedure.
the gas plant doesn't have any wells associated to it. So it's just a system on its own. So no wells, but the flow stations have wells as associated to it.
Yeah.
Okay.
Okay. So you're now asking how to calculate the contributions from the wells.
No, I'm talking about, okay, like, the condensate is produced from that gas plant. So now how do we now account, okay, how are we going to, at the end of the day, it is also sold out, like it is exported. So now when it comes back, now how do you now back allocate it to the wells at the end of the day, just like the way you back allocate to the fields?
Okay, so we could actually perform like, okay, for an oil well to get the rates, the individual rates on well, you need to perform well tests. So there are
Yeah.
also well tests performed for gas wells too. That's if
Okay.
it's a NAG well. So you
Yes.
can perform multi-rate tests, right, to get the rates from each of those wells. And then once you have the rates, you're able to establish the rates from those wells. So that's, you can now calculate, if you have your uptime, calculate the unreconciled production from each of those wells. So if you have the unconsidered production from each of those wells, you now you'll be able to, back allocate the volumes, right, from the gas plant to the wells using the production allocation calculations that I have discussed earlier on.
Okay. Thank you.
Yeah. So the second question. So does ArcGIS tool enable real-time data stream? Yeah, it does. It does. So like I explained, there are SCADA systems, right, in the field. So, and this SCADA system allows you to, retrieve data in real time. So in form of like a telemetry. So this data, once they are gathered, the sensors uploads them into, the cloud where it can be retrieved into the tool for further, analysis. So, and then in addition to that, schedule tasks too can be performed on ArcGIS, where you can schedule, this task will perform at this time, so that you don't have to manually do them yourself. So that can be achieved too on ArcGIS.
Okay, sorry, just to ask, sorry again. So what if in a situation whereby the real-time data stream, we have maybe a communication issue? So how are you going to estimate are you going to depend on manual data entry, or you do some estimation?
Yes, can you repeat?
I said in a situation whereby the real-time data stream has issues.
Okay.
Let's say for instance, the real-time data can give you 24 hours production.
Okay.
And let's say that they maybe in the field they had the IU card in the SCADA system has issues, and we're unable to account for that 24 hours stream and data production. So are you going to estimate what happens? What does ArcGIS? What does
Yeah,
that?
so since maybe there's a failure in your sensor and you're unable to get real-time data, you may have to like go back to your normal oil test, use your oil test with manual method basically, to get it to work. Then you can impute it manually in your system.
Okay.
So because since your real data, since there's a problem or since it's faulty, you can't really make out anything from that. So you have to go into an alternative route.
Okay. And there's a check button you can place maybe to state that it's a manual or estimated production.
Yes, yes. So
Okay.
there's an option. Yeah.
Thank you.
Yeah. Pleasure is mine. Okay, so in the absence of any further questions, let me leave the podium to our host, Mr. Osangwe.
Oh, thank you very much, Mr. Rotimi. Thank you very much, Temidayo. I really appreciate the time and the energy and resources you've put into this. We really do appreciate. Thank you everyone for joining. Since there is no other question, I think we've come to the end of this webinar, and I hope this IPES Accrete Energy Limited relationship continues. For now, we recorded this session and it will be made available on our LinkedIn. It will be available on our LinkedIn, and if you want it sent to your mail, you can just drop your email in the chat box and I'll copy it from there. Thank you very much. Yeah.
Thank you very much. Thank you very much, Osagwe, for your time.
Thank you, Osagwe.
Thank you.
Enjoy the rest of your day.
Yeah, thank you. You too. So you can drop your email and just exit the chat room.
Thank you. Thank you, sir. Thank you. I truly enjoyed the teaching. It was a great time. Thanks so much. It's time.